Hello and welcome to the videos for Shaughnessy's class, Math 30-2. This is Probability and Set Theory, Lesson 3. So you've got that. Probability and Set Theory, Lesson 3 is actually more of a review lesson than anything else. You end up taking a look at probability, and so we're just going to keep going. Please make sure you show up to class. So, going with this, okay, probability. I'm just trying to make sure this focuses here a little bit. Probability, okay, it's concerned with the possibility of an event occurring. That's what it is. You're worried about what's the probability that this happens, that happens, that this works, okay. It is expressed as either a decimal between 0 and 1, okay, or as a fraction, okay, one of the two. Probability isn't a percent. Percents are percent chances. Like if I say there's a 30% chance of precipitation tomorrow, that's something different. I'm not actually giving a probability. Technically, the probability for 30% would be 0.30, that conversion from percents to decimals. Okay, so the probability is given as a decimal between 0 and 1, and or as a fraction. Okay, so once you've got that done, then you've got the formula. Now the formula, okay, the probability of event A occurring, the probability of event A occurring is the number of favorable outcomes over the total number of possible outcomes. Favorable would be ones where this happened, okay? Now we often say this is the P at A, so I'm going to write that way out in front, P at A. Okay? P at A is the probability of A occurring, and it's the number of favorable over the number of possible. And in fact, you know that. You end up getting a fraction, because there should be fewer favorable outcomes than possible outcomes. Okay? So it's very similar. It's not percent chance, and that's what this next sentence is saying. Now, once again, we get to complement. Now, if you remember, the complement of sets was whatever is not within this larger set. Well, the probability of a complement event is the probability of A prime. Okay, what's the probability that it doesn't occur? That's essentially what it is. Now, the probability of a complement is 1 minus the probability that it does occur. Okay? Because 1 represents a 100% chance, and it's either going to occur or it's not going to occur. You don't have any in-between on that. So that adds up to 100. It's the probability of complements that add up to 1. If they're not complements of each other, they won't add up to 1. Okay? It has to be a complement. Okay? So if I start looking at things like this, if the probability that the airline loses your luggage on any given flight is 0.01, the probability they do not lose your luggage. Now, honestly, and I'm knock on wood, I've never had my luggage lost so far. So thankfully, I'm kind of good. But so if you have the probability that they do not lose your luggage is what they want to know. So the probability that it's lost is 0.01. The probability that it's not lost is the probability of L prime, which is 1 minus the probability of it being lost, which in this case would be 1 minus 0.01, which would be 0.99. So there's a 0.99 probability that they don't lose your luggage. And in fact, this is, most of the time they don't. They don't most of the time lose your luggage. They only occasionally do. Okay? So you've got this idea. That's complement events. Now, a coin is tossed and a regular 6-sided die is rolled. What is the probability of obtaining a 5 and a head? Okay. There's a lot of ways to do this. Okay. Probability of obtaining a 5 and a head. Now you can look at your sample space. A coin is tossed and a 6-sided die is rolled. So the coin could be heads or tails. And I'm just down here. Coin could be heads or tails. And you've got 1, 2, 3, 4, 5, or 6 that comes up here. Okay, or it could be tails. You've got 1, 2, 3, 4, 5, or 6 that comes up there. So really there are 12 possible events. You get a head and a 1, a head and a 2, a head and a 3, a head and a 4, a head and a 5, and so on and so forth. So this is going to be something over 12. Okay? Probability of this happening, I'm just going to call this A, is favorable over possible. So it's going to be something over 12. A 5 and a head. Okay, so a head and a 5 only occurs once. So that's a 1 in 12 probability. Done. Obtaining an even number and a head. Okay, there's supposed to be a space in there. An even number and a head. So a head and a 2, a head and a 4, or a head and a 6. There are 3 of those. So the probability of this happening, I'm just going to call it B. There are 3 favorable events out of the 12 in total. So it's 3/12. Of obtaining an even number. Well, in this case here, and I'm going to call this C, the probability of C occurring, I could get the 2, 4, 6 there, or I could get the 2, 4, 6 down in tails. Okay, so there are 6 out of 12. Okay, D, the probability of obtaining a tail. Okay, probability of D. Okay, there are 6 outcomes down here in tails. Okay, it's underneath the letters. There are 6 outcomes down here in tails, so it's going to be 6 out of 12. Now, technically those aren't quite finished, but nonetheless that's what's going on. Now what you do, because you know you do this with fractions, is you reduce 3 out of 12 becomes divide by 3, 1 out of 4. 6 out of 12 becomes 1 out of 2, 1/2. 6 out of 12 becomes 1 out of 2, or 1/2. So truly that's what it boils down to. But nonetheless, the idea that probability is favorable over possible happens to be all along. Now E, why is the sum of the 4 items listed above not equal to 1? They are not complements of each other. Okay, they're not complements of each other. That's why they don't add up to 1. It's not this or this happening. It's not you've got all the different complements. Okay? So you can add up all probabilities, and somewhere along the line somebody says probability always adds up to 1. It's true, but only when it's complements of each other. If it's not complements, it's not true. Okay? So once you've got this basic idea of probability, then you can look at this. Okay? Toddler is arranging 5 DVDs on a shelf. What is the probability that they are accidentally arranged in alphabetical order? Now hang on, let me focus this because it's not clear. A toddler is arranging 5 DVDs on a shelf. Okay? So you look at this and say, okay, accidentally arranged in alphabetical order. So the probability that it is arranged in alphabetical order, and I'm just going to write probability ORD, okay, is the number of favorable outcomes over the number of possible outcomes. Okay? Favorable outcomes, there's 1. It's either in alphabetical order or it's not. So 1. There's only one way it's in alphabetical order. The possible outcomes are a little bit harder to figure out. You're asking yourself, how many ways can you arrange 5 DVDs on the shelf? Basically, it's asking you how many ways can these DVDs be arranged? Now, you've seen this question before. How many ways can 5 DVDs be arranged? If you're arranging them, then the order is mattering. And so you're starting to think about what's going on here. This is a perm and com. Perms and coms can show up here. Favorable over possible. Okay, favorable is 1. Possible is 5. Pick 5. So you're back to perms and coms. How did I know it was perms and coms? Honestly, because when I'm looking at this and I'm thinking, how many ways can I arrange this on a shelf? It's not something as simple as I can look at it and imagine this happening. Okay, because I could have Star Wars before the next DVD, Anchorman, or I could have it behind, and there's so many different possibilities, because once you put the 5 DVDs in, then it gets really complicated. That's where you say, okay, there has to be an easier way to figure this out, and there is. Perms and coms is the easier way. So it's a 1 in 120 probability that this toddler, randomly doing it, and the reason it's a toddler is he doesn't know what alphabetical order is. Okay? There's a 1 in 120 chance that this toddler is just going to randomly get it alphabetically. And it's possible. It's that infinite number of monkeys with an infinite number of typewriters thing. It is possible. Okay? Although this is only 5. Okay? Now, this one here, there are 3 different coins, a dime, a nickel, and a quarter. They are tossed at the same time. Okay? So I'm going to tree diagram for this, a sample space, the dime, the nickel, and the quarter. The dime could come up heads or tails. After the dime comes up heads or tails, the nickel could come up heads or tails from there. So you could either get a head on the dime and head or tail here. Then you can get a head or tail, head or tail, head or tail, head or tail. I like sample spaces. I like tree diagrams. I find they make probability quite a bit easier. You don't have to, okay? But I can look at this and say, okay, there's 1, 2, 3, 4, 5, 6, 7, 8. There's 8 possibilities. Every time I do that, the possible is going to be 8. Okay, so I've got that. So the probability of obtaining a head on the quarter. So I'm just going to write HQ for head on the quarter. The probability of getting a head on the quarter, there's 1 here, 1 here, 3, 4. There's 4 ways that happens. Possible is 8. So it's a 1.5 probability. You just reduce the fraction. Okay? Going from there, probability of obtaining a tail on the nickel and a head on the dime. A head on the dime and a tail on the nickel. Head and a tail. So that's this branch. Okay, head and a tail. And I could either get a head or a tail on this last one. So there are 2 good ways that this could be done. So the probability of a nickel tail and a head on the dime. Okay, nickel tail, head, dime is going to be, there are 2. There are these 2. Okay, they're in that branch there. So there's 2 out of 8, which reduces to 1/4. Okay. Continuing on with this, the probability of obtaining 2 tails. Now, my sample space is getting a little bit messy, but I'm looking at that. So to get 2 tails, it's not a head and a head, it's a head and a tail and a tail. That's there, 1. That's got a tail on the nickel and the quarter. So head, tail, tail, that's 1. Tail, head, tail, that's 2. And tail, tail, head, that's 3. So there are 3 of those that are good out of the 8. And you'd reduce it if you could. Okay, that much is done. Okay, obtaining more than 2 tails. Now you can look at this two different ways. You get the probability of 2 tails or the probability of 3 tails. Okay, or you could just count. Okay, the 2 tails I already did was 3/8. There is a 3 tails option. It's this last one down here. So there's one option that does, 1 out of 8, which using fractions would be 4 out of 8, which reduces to 1/2. Okay, so that's getting more than 2 tails. Okay. Okay, so you've got this sort of idea. So when you're done, all of this just goes together. This is some probability review. There's not much to it. It's not like it's new, but please make sure you take a look at your homework and show up to class. Thank you.